हेलो एवरीवन, वेलकम टू माय चैनल रूट टू मैथमेटिक्स। आज इस वीडियो में हम करने वाले हैं सिंप्लीफिकेशन। सो विदाउट एनी डिले लेट्स स्टार्ट सिंप्लीफिकेशन ऑफ दिस प्रॉब्लम. So the given problem is 3 root 7 divided by root 5 plus root 2 minus 5 root 2 divided by root 2 plus root 7 plus 2 root 2 divided by root 7 plus root 5. So one thing is common in this problem is that all the denominator values are in radicals, that is in roots. So first step to make the calculation easy or simplification easy, we need to remove or eliminate these roots from the denominator. The only one method can be used to eliminate these roots in denominator is the rationalization method. So through this rationalization method, we can eliminate roots from the denominator, right? So let's take this as a first term and this one as a second term and this one is a third term. So first step is to rationalize the first term. So our first term is 3 root 7 divided by root 5 plus root 2. So let rationalize it. 3 root 7 divided by root 5 plus root 2. Rationalization means you have to multiply and divide the same term which is present in the denominator, but you need to change the sign. Here you can see that in denominator there is a positive sign root 5 plus root 2, but in rationalization method you have to multiply the opposite sign term. All the terms will remain the same, only the sign will be opposite. So then multiplying we get 3 root 7 into root 5 will get 3 root 35. Okay, and minus signature is here. 3 root 7 multiplied with root 2, 3 root 40. In denominator you can see that here it is root 5 plus root 2 and here root 5 minus root 2. Here you can see that if I consider root 5 as a and root 5 as a and root 2 as a b, then I can put this algebraic identity, that is a plus b multiplied with a minus b will be equal to a square minus b square. I can put this identity here. So what I'll get is 5 minus 2, because root 5 square minus root 2 square, that is nothing but 5, and root 2 square is nothing but 2. So by simplifying, I'll get root 35 minus 3 root 14 divided by 3. If I take 3 common from the numerator, so root 35 minus root 14 divided by 3. Though these 3 will get cancelled out, and I'll get, after rationalization, I'll get root 35 minus root 14. Okay. So after rationalizing this, what I get. Next step. Then let's similarly rationalize the second term. The second term is 5 root 5 divided by root 2 plus root 7. Similarly, in rationalization method, you have to multiply root 7 minus root 2 divide by root 2 plus root 7 multiplied with root 7 minus root 2. Okay. What I'll get is 5 root 5 multiplied with root 7. I'll get 5 root 35, and 5 root 5 multiplied with root 2. I'll get minus 5 root 10. Similarly, by applying the algebraic identity here, what I'll get is 7 minus 2, that is nothing but 5. So if I take 5 common, root 35 minus root 10 divide by 5. This to get cancel out. In the second term we are getting root 35 minus root 10. Okay. So in the second term we are getting root 35 minus root 10. Then same rationalization method I will apply in the third term also. This one is the third term. So by applying rationalization method in the third term, what we'll get is, third term is 2 root 2 divide by root 7 plus root 5, that is equals to 2 root 2 divide by root 7 plus root 5 multiplied with, the terms will remain, only the sign will be changed. Root 7 minus root 5 divide by root 7 minus root 5. So 2 root 2 multiplied with root 7 will get 2 root 14 minus 2 root 10 divide by 7 minus 5 by applying the algebraic identity. So we will take 2 common, root 14 minus root 10 divided by 2. This 2 get cancel out, we will get root 14 minus root 10. So by rationalizing all the three terms, we get root 14 minus root 10. Let's put this rationalization terms here. So what we'll get, 35 minus root 14 minus of root 35. As here is a minus sign, you can see that. So this negative sign will become positive, root 10 plus root 14 minus root 10. So now root 35 minus root 35 get cancelled out. Root 14 here plus root 14 get cancelled out. Root 10 minus root 10 is getting cancelled out. So the answer we get is 0 is the answer of this problem.